All right, so lesson 3.1 here. I just wanted to go further up. Normally, they will give you a variable that you should be using. If I don't, you assign something that makes sense within the context, right? But in this case, it would be TC instead of XY, okay? T for time, C for Celsius. All right, example 3. The graph shows the fuel consumption of a scooter with a full tank of gas at the beginning of a journey. Write the coordinates of the horizontal and vertical intercepts. Describe what they represent in this scenario, right? So horizontal intercept would be, it happens right here, right? So at 200, 0, that's our x-intercept. This represents, right? This represents the distance a scooter can travel on a full tank of gas. Okay, that's what that represents. 200, like if you have a full tank and the volume of the gas goes down, right? At this point, you have no more gas left. And your distance at that point is 200 kilometers. So you would be able to travel 200 kilometers and on a full tank of gas. Or you could also write, I would also accept, right, that you will, when the gas tank is empty, you will have driven 200 kilometers or something like that. Okay, vertical intercept, that would be this one right here, which is 0.8. And keep in mind, now everything means something, right? So how about we do that? The distance and volume, we'll call it D for distance, V for volume, like that. Okay, so in this particular context, we're using dV instead of x and y. Okay, anyways, the vertical intercept, what does that represent? Okay, the initial volume of gas in the tank, prior to the journey, prior to starting the journey or departing or whatever you want to say there. What are the domain and range of this function? Are there any restrictions on the domain and range? Explain. All right. So for domain, you could say that you're going from 0 to 200, right? And it's both inclusive. Most of the time for word problems, that is the case. And for range, it would be 0 to 8, right? Because if you think about it, you're scanning it from the bottom, right? It starts at y is equal to 0, and the highest you can permissible value is 8. So it's that. Or 0, now we're going to use D, right? Or 0, V, 8. Okay. What are the restrictions on the domain? What that means is, in this case, you do not have, you couldn't have negative, and you couldn't have a negative value, for example, when it comes to volume. Like this line could not continue here. You'd have to restrict it to stop right there. When you're empty, that's it. You can't have a negative volume, right? And so there is a restriction on this word problem, and the domain and range take care of that. But also, distance and volume only have meaning with positive values. Okay, a negative distance would also not make sense, right? So that's the restriction. Restriction here is talking about that. What is the fuel consumption in liters per 100 kilometers? Well, that's interesting. Per 100 kilometers. So that sounds right. Liters per 100 kilometers. You're almost talking what? That's a rate of change. That is rate of change. If you see something per something else, that's the rate of change. So here we have rate of change. What would be my dependent there? That's delta of dependent, delta of independent. Okay, let's write down, just to go back here, are these 2 points on this graph? And you'd have to say yes. This one is 200, 0. This one is 0, 8. This one is more to the right. Okay, so we have to subtract the y values, and we also have to subtract the x values, right? And that would give you negative 8, and that's liters over 200 kilometers. There you have it. Could you turn this into 100 kilometers? Absolutely. You can just divide them both by 2. And there you stop it. You could keep going, but we'll just stop it there because that's what they asked for. Right? So there it is. And because of the negative, right, you can say that, for every 100 kilometers you drive, the volume in the tank decreases by 4 liters, right? For every 100 kilometers driven, the volume of gas decreases by 4 liters. And the decreases takes care of the negative, okay, in front of that rate of change. Now, if this had not said per 100 kilometers, you would have kept on going, right? 4 goes in there once, it goes in there 25, so it'd be 1 over 25, negative 1 over 25. All right, next page. We're going to check for understanding. Find the coordinates of the intercepts. What do they represent? Right, so vertical would be a 0, 10. What does that represent in this particular case, right? Height of a burning candle. So at 0, the height of the candle is 10 centimeters, right? So at time 0, so the initial height of the candle. That would be basically prior to being lit, all right? The horizontal would be, what is this, 45, 0, right? What would that say? The time for the candle to burn completely is what? 45 what minutes? 45 minutes. The initial height of the candle is 10 centimeters. Let's put that down, right? Be very specific here. What is the rate of change? Again, you have those 2 points there. Rate of change. Let's subtract our y values. Which one is more to the right? It's this one. So 0 minus 10, and then it's 45 minus 0. That'd be negative 10 what? The y values would be centimeters over 45 minutes. Okay, and that can be further reduced to 5 goes in there 2 times. 5 goes in there 9 times. Okay. Also, if you wanted to, you could, if you're allowed a calculator, you could also just divide it right here and just round it to 2 decimals. So it'd be negative 0.22 centimeters per minute. Because you're basically asking yourself, 9 goes in there, how many times? 9 goes in there one time. So that would be a unit rate. Okay, but let's stick to this. That's what we're after in this course. If you do have on the exam or whatever, you will be able to use a calculator. In fact, I can't really check whether or not using a calculator for these questions, even though you normally wouldn't try to stay away from a calculator. Okay, what's the domain and range? The domain, in this case, you go from 0 to 45. And the range, you would go from 0 all the way to 10. Okay, or let's do this again, right? We're gonna have to assign t for time and height for h for height, right? So this would be 0 or 0 to 10, like that. Okay, all right, let's see if we can finish this page with what we have left here. All right, use the intercepts to sketch this graph. So I'm going to pause it here. You go ahead and try this. You have 2 examples to go by, and I'll just fill it out and press play when I'm done. All right, there it is. I used x is equal to 1. You know, you could have used x is equal to 3, whatever you wanted to. You could even use negative values if you want, but I would just keep it simple there. So notice that I have my equation, I've got labeled all points, I used arrowheads, there's no context, so it just keeps on going forever. Just pause it there and write it down. We're not going to do 4, but if you're curious, it's 3.25 hours. If you're interested, it can be done, but we're not going to do it now. And it says here the graph below shows how the temperature changes over time at different location. Match each graph to its rate of change and vertical intercept. Okay, so you basically have to match. You have a -8 vertical intercept, so y-intercept, and a rate of change of 1. So where would you go with that? -8, these two have a -8 starting point. And how could you check if it has a rate of change of 1? What does that mean, a rate of change of 1? Well, if you think about it, it means that both the y and the x are changing by the same amount. So if you're going up 10, then you're going to go over 10 because, right, 10 over 10 is 1. And so that's what you want to do here. You want to check for that. And so basically, I'm going to ask you to find the rate of change for all of these, and then you match it. So I'll do that on the side, and you see what you come up with. So here I did it for graph A, right? You have your 2 points given. Take the one, right? The right minus left. So 16 minus 0, 12 minus 4, that gives you 16 over 8. That is exactly 2 degrees Celsius per hour. So that means it has a rate of change of 2. So this graph starts at -8 and has a rate of change of 2. So graph A goes right here. Graph A. The rate of change for graph B, if you do the math, you get a -2, which you're expecting, right? You're expecting it to go down, so that'd be this one here. So graph B goes there. So graph B is equated with this, therefore graph C has to go with the first one, all right? Okay, so I'll put the homework up. So there's your homework. All right, take care, stay safe. That's the end of this unit.